Hi, my name is Dana Golden. Today we're going to be going through the statistics intro in Python with just a little bit of statistics functions. I want you to get used to understanding what different statistics functions are and how you can calculate different distributions in Python. So we're going to import a bunch of packages. We're going to create a data set. This data set we're going to create as just a list of numbers. We're going to take the mean using np.mean. We can take the median using np.median. Take the mode using converting to a series, getting the mode and getting the first observation through 0. Mode is 20. Mode is the most common number, so let's see 20 appears twice. Variance equals np.var of data. Standard deviation, it's going to be a square root of the variance. So if we did standard deviation squared, notice we end up back at the variance. Range, this is the smallest number taken from the largest number. So we get 80. Interquartile range, this is the difference between the third quartile and the first quartile. So that's 45. So notice the first quartile, Q1, is 22.5 because it's an average between 20 and 30. And then the third quartile is an average. Yes, not true average, but yeah, it's between 20 and 60 and 70. And then with the binomial distribution, we create our parameters of the distribution, n and p, where n is equal to 10 and p equals 0.5. This means that we're creating 10, this is the probability of successes in 10 observations with 0.5 as the probability. So for 5 successes in 10 observations, we get 24% of exactly 5 successes. Poisson distribution, we have our parameter lambda, and now we want to get the same for 5. So with a k equals 5 number of successes, with a lambda of 3, the Poisson distribution gives this probability. Normal distribution, we have a standard deviation of 1, mean of 0, so this is a standard normal distribution. We're going to take the normal PDF with the mean and standard deviation. We're going to print the PDF of 0. Then we're going to do the same for the uniform distribution with the uniform PDF of x equals 0.5. And then with the exponential distribution, we're going to do lambda equals 1. And then we're going to create a scale parameter of 1 over lambda, and then we're going to print PDF equals 1. So for normal PDF, the PDF for x equals 0 is 0.398. The PDF for x equals 1 is 1, and the PDF for x equals 1 for the exponential is 0.3678. So now we're going to do a one-sample t-test. So we're comparing this sample to the population mean, seeing if it's different. So I'll give you a moment to pause to see if you think that it's going to be different, what the p-value is going to be. Remember that this is just a z-test, but t. So we're subtracting the mean from sample mean from the expected mean and dividing by standard deviation. This is the two-sample t-test. So we're going to take t-stat, p-value, sample data 1, sample data 2. We're going to do the same thing with a chi-squared test. So there you have it. 3 separate test statistics. So the first one, we fail to reject the null hypothesis because we have a very high p-value. Second one, we reject the null hypothesis. So what that means is that these 2 samples are not drawn from the same distribution, we can say. And the third one, we also fail to reject the null hypothesis. We say that these are drawn from the same distribution of counts. Or we can't say that they're not. So now we create some random data for visualization. And we plot a histogram showing values and frequencies. We then plot a density plot, and then we plot a box plot. So here's some matplotlib plotting. We just create histogram, density plot, box plot. And that's your statistics intro in Python. Hope you have a great day.